Today I am discussing a very important topic, not only in general course but also very important for honors level. So magnetic potential at a distance are due to a magnetic pole. This is very important relationship between V and R. First, we have to draw a diagram that is point O. Here M is situated and this point, that is P, and this point, that is Q. Distance from O to P, that is R, and this distance P to Q, that is dx. Now we have to find out the actual relationship. So a magnetic pole M is at point O. The distance between P and O is, that is R. Let a unit north pole is brought from infinity at Q. The force acting on the unit north pole is F equal to, we can write, that is mu 0 by 4 pi m by x square. This is for small displacement, dx. The work done is dw, that is f dx. So dw equal to mu 0 by 4 pi m x square into dx, putting the value of x, putting the value of f. So magnetic pole, the magnetic pole show the magnetic potential at point P. Magnetic potential at point P, we can write that is dV equal to that is mu 0 by 4 pi m by x square into dx. Here we have to put that is negative sign. So now mu 0 by 4 pi m dx by x square. Now infinity, that is we can consider this is 0. Now that is r, so this is v. When the charge is infinity, then this is 0. When the charge is at infinity, then the potential 0. When the charge at so from this integration we can say when the pole is at infinity, then potential 0. When it is at r, then we get v. So that is v equal to mu 0 by 4 pi m, so minus sign, minus 1 by x 0 to r, so v equal to, we can get that is mu 0 by 4 pi into m by r. This is the relation of potential between r and v. So this is the potential. So this is the relation between the potential and the distance. Next topic is that magnetic dipole. So magnetic dipole moment. So magnetic dipole moment, so we draw a diagram. This is n and this is s. The distance n and s, that is 12. Let m be the pole strength, so and 12 is the magnetic length. So magnetic dipole moment is denoted by m. So m equal to that is 2L into M, that is magnetic strength and separation between the poles. And in another format we get for single turn, M equal to I into A, that is in case of loop. So this is current I and area A. So in this case we consider in this equation, so A is the area of the loop carrying current, that is I. For n number of terms, that is we can write M equal to n I A. So this is the relation of loop or coil. So this is the relation of, that is coil. So magnetic moment of a coil, is, that is M equal to NIA. এটা for n turns, M equal to IA, that is for single turn, So unit of M in SI system, that is ampere meter square. So today we have learnt the magnetic potential and also magnetic dipole moment. So now today's class has been ended up. I think this class will be very much helpful for each and every students of B.SC student. So please like, share and subscribe and also comment. I will regularly uploaded different types of videos relating honors level and general course.